Alright, good morning. So I'm just going to be going over a quick Chapter 5 summary on kind of the four main sections of the test. So I just wrote the test, and there's going to be 25 questions. So for understanding wise, we have around 10 questions. Okay, so what does this kind of go under? It's kind of understanding that there's different ways to represent relations, and that some of them are sometimes functions if they pass a certain rule. So there's a lot of different ways to represent. If we remember, there's a XY table or a T table. There's these weird circles where you have one which is X, the other one which is Y. There's these curly brackets with a whole bunch of points listed. Individual points listed, where one's an X, the other one's a Y, the other one's an X, the other one's a Y, and so on. Generally, if it's listed in this, then you have a certain graph. But another way for a relation or a function was a graph itself. So an example, maybe something like that. There's a graph. One thing to note is this one here would never be a straight line like this, because anytime you have a straight line or where you hold down the pencil and you draw a line, it means there's an infinite amount of points in there. So you would never be able to list everything off like this if you had drawn a line. So if it's ever like this, it's more so like a graph with dots, because it only lists points. Okay, so those are different ways of writing relations, or maybe a function. And then here's another way as well, where you have some sort of equation, which kind of, if you have an equation, you want to go to a T table to see what everything would be. And we normally went -3, -1, 0, 1, and 3 for our X values. And we wanted to see what our Y values would be from that. Okay, so it's really understanding graphs and how there's different ways to represent the same graphs. So different understanding pieces as well are kind of like knowing that this is the x-axis, this is the y-axis. Another way you can kind of understand that is the x, you must remember, is domain, and it's also the independent. The y is always the range, and the dependent, which means it depends on the x one. Another thing to write here is x is always the horizontal axis, and the y is the vertical, which means up and down. Okay, so there's all these words to remember, but they all kind of correlate together always. Okay, so those ones always correlate. One thing to remember is kind of this word here, function. Is it a function? That kind of has been going throughout. So if you remember, function is if you take a piece of paper, say this line, let's see if that's a function. The function definition is, does a certain x value, say you pick that one, have 2 y values? Well, if you go up to the line, it only has 1 right there. Okay. An example of something that would not be a function would be something like this, where if I chose a spot like there, it would have 2 y values there and down there. Okay, so not a function. This is a function. And how you test on graphs is you take a piece of paper or a ruler and you kind of go along, and if you ever hit 2 spots at the same time, it's not a function. It's a quick way of doing it. So if I do this one, instantly I'm hitting 2 spots down there and up there. Okay, so that one's not a function. Alright, another thing to remember with this understanding piece is when to draw a solid line or when to just have dots. And this depends on what your y-axis and your x-axis is. So in this case, y-axis is maybe number of cars. I'm just making this up. And then x will just say at a certain time. So say this is the number of cars on a highway at a certain time here. So here we might ask, do you want to connect the dots? You have to ask yourself, can you have fractions of cars? Okay, or fractions of whatever this is in the question. So, can you have fractions of cars on a highway? Not really, right? So you would not want to connect the dots for this question. But certain other questions you might want to connect, maybe like ocean waves over time again. For this one, height. For this one, it is it's called continuous graph because you can have a fraction of a height. You can have 0.5 meters. That's totally okay. So that one you're allowed to connect because you're allowed to have fractions. They don't have to be whole numbers. So that's one kind of understanding piece with this. Okay, so there's all these different pieces with understanding and being able to understand graphs and kind of what they mean. Another piece here is saying for this graph, what is the range value when the x value is, say, 1 right here. So usually you go to your 1 and you go straight up or down until you hit the graph. And then you have to go straight sideways until you hit your y-axis. And that's where it'll tell you what value it is at this x value. So there's lots of understanding pieces, but there's 10 questions on that overall. And then we jump into the domain and range kind of section. So this might have 5 or 6 questions. So an example here is if you want to find the domain and range. Here you usually use squiggly brackets again when you have just dots, because you have to list a certain finite number of values. So here you could either do domain or you can do range. Domain here might be, let's just make up numbers, -3, -1, and then we'll go 1 and 2. So that would be maybe the domain of this. I don't have any values, so this is being very rough. And the range would be a similar thing, but we go maybe say -3, and there's 2 of them at that height, and then there's 2 of them at 1. So that's the range of that graph. Okay. Another question is that a function? You would just do the line test. You hit 1 there, but you don't hit 2, so you're fine. You hit 1, you don't hit 2, so you're fine. 1, you're fine, and 1, you're fine. So that is a function. Another example here is domain. This time it's continuous, which means there's an infinite amount of points on that line. But here you don't include that point, so it would be a round bracket. And then here you would include it because it's filled in circle. So generally with the domain, just like that line test, you go left to right to see what the domain is. The first point you would hit would be the start of the domain. The last point that you would hit would be the end of the domain. You would look on the x-axis to see what point to use, because domain is always x. And then range, we have to remember that range is always the y-axis. That's when you flip the page the other way and you go up instead, and it's asking what's the first y value that you hit. Well, it's that circle there, but just a tiny bit more. That's our first y value that we hit, and we keep going till it stops hitting the graph, which will be right up there. And then we have those two, which is, this is a non-filled in circle, so it'll be like that. And then this one here is part of the line, so it will be a square bracket like that. Okay. I don't have values on this graph, that's why I'm not putting numbers in, but that's kind of the idea. Alright, function notation, this one's really confusing. F of x equals 8x plus 2, I just made that up. And it's kind of understanding this. How many questions will we have on this? We might have 2 or 3. 8x plus 2. There's 2 types of questions they always ask you with this. And one is, what is f of 3? Would be a question. Or what is the y value when the x value is 3? That's what it means. So generally with these questions, you always switch out this f of x here is really a y. That's what it means. So you can always rewrite it like this. It means the same thing. Y is 8x plus 2. Okay, so once you have that, it's saying what is f of 3? So if we look, the 3's in the brackets and the x is in the brackets. That means the 3 is the x. Okay, so now we can go y is 8, 3 instead of the x there. Then we got to do a little bit of math. 8 times 3 is 24, plus 2 is 26. So our y is 26. And what this means is when our x value is 3 on our graph, whatever the graph is, because every equation represents some sort of function. This one might be something like this. Saying when our x value is 3, our y value is going to be way up there, 26. Alright. So once you get that answer, you can always bring it back, because we switched that f of x to a y there. So if we want to go back to f of x form, we switch the y back to an f of x. But this time instead of x, we write 3, f of 3, and then we write our 26 again, and then we're done. So that's one form of question you get with function notation. The last possible type you could get is what is x when f of x is, say, let's just make a number 10. So in this question, that's the second type you can get. You just write your equation to start off. And then it's saying f of x is 10. Okay, not this time. X, they're not telling us what it is, but they're telling us what this whole f of x is. If you want to make it more simple, you could, again, switch it to y equals 8x plus 2. And it's saying, what is x when y is 10 is what it really means. So if you put a 10 in there, then you have this equation. You have to solve for x, which means get x by itself. So we're going to minus this 2 onto both sides. And we'll get 8 equals 8x. And then we have to get x by itself still. So we have to do the opposite of times, which is divide. So let's divide by 8 on both sides. And we end up with x equals 1. Okay? And what does this mean? It means that when your y value on your graph, whatever it looks like, when your y value is at 10, your x value has to be at 1. Okay? So that means at 1, it's going to be all the way up on 10. That's going to be a point on your line, whatever the line looks like. Okay? And again, our line is the same one here because it's the same equation. And the equation means the line. It looks the same as the last one, like that. So those are the two function notation types of questions that you could get. Alright, last part, linear relations. This one has a big section of questions. This has around 8 to 10 questions. Around 8 questions, understanding linear relations, which is our last lesson. And it kind of goes over things called intercepts, which means when the line, because linear means straight line, crosses your y-axis and here your x-axis. Okay, so this is the y-intercept because it's on the y-axis right there, and this is x on the x-axis. And then a big word too is rate of change. You have to know how to find that. So, and kind of understanding how to tell people different x and y values on this graph. Okay, so if you want to find rate of change, again it's change in y over change in x. So generally in this you choose 2 points. So say I chose these 2 points here. Any 2 points will work. The first point, which is the farthest on the left, is called, we'll call it point 1. And then the one on the farthest on the right is called point 2. So generally, if you go the y value of point 2 minus the y value of point 1, you'll get the change in y. So I can go y2 minus y1. The 2 and the 1 just means 0.2, and the 1 means 0.1, the y value of that. So say this is -3, 0, and then this one we'll say is 0, 2. Then here you would go the y value minus the y value there, so it would be 2 minus 0. But the change in x is x2 minus x1. That's your change in your x value. You always go the x value of the second one, the furthest right one, minus the x value of the first one. So overall y2 of 0.2 is 2. The y value of the first point is 0. X value of the second point is 0. The x value of the first point is -3. So -3 in brackets like that. So overall it's going to be 2 over negative is a positive over 3. So our rate of change of this linear or straight relation is 2 over 3. Okay. What does that mean? It means that for every x value that you move over, the line will go up 2/3 or 0.666666 units up. Okay, so that's the rate of change. It's important to know what that kind of means, but most questions just ask you what the rate of change is. Okay. Another thing that you need to know with linear relations is if you have an equation. I'm going to write a linear relation equation right now. So let's say 2x plus 1. So you might have to know how to draw the graph from the equation. And how you do that is always an xy table, where you have -3, -1, 0, 1, and 3. And it's where you plug these x values in for the x values here, and you see what the y is going to be. So -3 times 2 is -6, plus 1 is -5. So that's the y value for that x value. Now we do the same thing with this x value. -1 in there is -2, plus 1 is -1. And so on. So then you get all these points. We just got 5 points. And you can draw your line. It will look something like this. Once you do it, you label each one -3, -5. So that one would be right there. -1, -1, something like there. 0, 1 right there. 1, 3 maybe up there, and 3, 7, which would be up there. And then you could draw your line. Okay. So from the equation to the graph, you always need a table of values. Okay, so that's a quick summary before your Chapter 5 test. Thank you.